For today, we are starting first with operations with functions, which is pretty easy. Your operations, if you remember, are your add, subtract, multiply, and divide. So these are just our notations for it. F plus g of x. That just means you are adding your f of x plus your g of x. You're just adding your two functions together. It's pretty easy. So over here next to it, when it says f minus g of x, that just means you're taking f of x and you're subtracting g of x from it. You just go in the order of the letter, so f minus g. What do you think we're doing down here for this one? Yeah, you're just multiplying them. So you're multiplying f of x times g of x. So for all of these, you're going to have x's still in your answer because it's still f of x and g of x. You don't have numbers that you're plugging in right now. So quotient, that means we're dividing f of x divided by g of x. Your hint for this one is a lot of times there's going to be a whole bunch of factoring involved. This kind of goes back to our first unit, which you guys didn't really like them. When you're dividing and you have x's, squareds in there and whatnot, you have to factor and cancel, just kind of like on our algebra set we just turned in. So then a couple other things. If we have 2 times f of x, that means it's 2 times the function. So you would take a 2 and you would distribute it through and multiply it times everything that's in that function there. Which that is different than our next one. F of 2x means you plug in 2x for all x's. So anywhere you see an x, you're going to plug in a 2x. And that does give you a couple of different answers. Like, for example, if you're plugging it in and there's an exponent there, 2x to the 3rd power is going to be very different than if I multiply x cubed times a 2. Here, we're going to plug in negative x for x, which again is different than this last one here. This is where you just negate the whole function. You just negate f of x. You're just multiplying everything times a negative 1 basically. It does give you different answers. There are differences to it. So let's take a look at our examples. All of our examples down here are going off of our two functions right here. F of x and g of x. F of x being 2x squared minus x, g of x being 2x plus 5. So the first one here, they want us to add the two of them together. So again, our f of x is 2x squared minus x. We're going to add to it our g of x, so our 2x plus 5. So then we just need to combine our like terms. Negative x plus 2x gives us a positive 1x. So 2x squared plus 1x plus 5. That's our final answer. So the one to the right of it is telling us to do what? Subtract. This one's telling us to do the g function first. So 2x plus 5. Minus, and I'm going to use parentheses, our f function, which is 2x minus x, 2x squared minus x. I put my parentheses in there because we have to remember this subtraction sign needs to be distributed to both things in there. So it becomes a negative 2x squared and a positive x because of that subtraction. So our x squared term has to go first, so negative 2x squared. Combine our x's, what do we get? 3x. And then plus our 5. And that would be our final answer for that one. So then our next row, f plus g of negative 2. This is telling you to add the functions first. And then once you've added them together, you're going to plug in a negative 2. But the convenient thing for us is, didn't we already add them together? Yeah, we did. We did up here in this one. So all I'm going to do is plug in a -2 now for all of my x's. And this one above, because that's when I added them together. So following our order of operations, -2 squared would be a 4. So I have 2 times 4 minus 2 plus 5. Which would that give us as our final answer? 11. Because we would have 8 minus 2 gives us 6 plus our 5 gives us 11. So again, in our one next to it, it's telling us to do g minus f first, but didn't we already figure this out? We did. So what are we going to plug into it? 3y. So I'm going to look up here. I'm going to plug in 3y. So -2 times 3y squared plus 3 times 3y plus 5. So I'll take care of my exponent first. 3 squared gives me 9. And then y squared gives me y squared. And then my 3 times 3y gives me a 9y. And then plus my 5. So one last thing to do, multiply by -2 times my 9y squared, so I get -18y squared plus 9y plus 5. That's our final answer for that one. So you're going to have just purely a number answer when in the parentheses you're given a number. If you're given a letter, like all our other ones, you're going to have that letter as part of your answer. You're not going to get it down to a single term. Okay, this next one, what's it telling us to do first? Multiply. I got to do f times g. So 2x squared minus x times 2x plus 5. Nope, right here. Fg, that's multiply. So then we'll go ahead and we'll distribute. 2x squared times 2x gives us 4x cubed. 2x squared times 5. Yep, 10x squared. And then we'll distribute our -x times 2x. And then -x times 5. So then we'll combine our like terms here. I got some x squareds to combine, so I get 4x cubed plus 8x squared minus 5x. So now that we've multiplied them together, what does it tell us to plug in? 2a. So this is going to be 4 times 2a cubed plus 8 times 2a squared minus 5 times 2a. So we'll do our exponents first. 2 cubed gives us 8. A cubed is a cubed. Then plus 8 times 2 squared gives us 4. And then a squared. And then we can just multiply that last one already. There's no exponent out there, so minus the 10a at the end. So we're almost there. A little bit of multiplying now. 4 times 3a cubed gives us a 32a cubed. So again, 4 times 4, or 8 times 4. 32a squared minus your 10a. And that's our final answer for that one. Yes, there is an a. You could do a GCF factor out of a, but you don't have to do that. They didn't ask you to do any factoring here. You're right, you could. Okay, so the one to the right of it, what's that one telling us to do? Divide. F function goes on the top. G function goes on the bottom, so 2x squared minus x over 2x plus 5. So we have to ask ourselves, can we factor anything there? Yep. What's my GCF up here? So it's x times 2x minus 1 over 2x plus 5. And then can we reduce anything? Unfortunately not. So this really ends up being our answer. There's nothing else you can do to that. A lot of times when you end up factoring, then this stuff in the parentheses is the same as the denominator, so then you can cancel them out. No. It's all or nothing when those plus minus signs come together. So 2x minus 1, that whole thing has to go or none of it goes. And then the 2x plus 5, the whole thing has to go or none of it goes. All right, so our next one, we have this negative out in front of the g, and they're telling us to plug in a what? Negative 3. So I'm going to put the negative out in front, and then it's going to be 2 times negative 3 plus 5. So 2 times negative 3 gives us what? And then negative 6 plus 5 gives us a negative 1. But we had that negative sign out in front of the parentheses, so what happens with negative negative? Cancel makes it positive, so we have positive 1 as our answer there. Next one's telling us 1/2 of f of t. So that means I'm going to have this 1/2 here, and then I'm going to take my f function and plug a t in for it. So instead of 2x squared, I get 2t squared minus t. So now what do we do? Distribute our 1/2. So 1/2 times 2 gives us 1t squared. 1/2 times the 1t gives us 1/2 t. Then that's our final answer. So our next one, what are we plugging in? Negative x. So I'm going to have 2 times negative x squared minus a negative x. So what happens to our negative x when we square it? Turns it to a positive x squared. So we have 2x squared here. And then minus a negative turns it to plus x. So 2x squared plus x. And then our last one on this first page, what are we plugging in? 1/2 x. So it's going to be 2 times 1/2 x plus 5. Okay. So what's 2 times 1/2? 1. So we got x plus 5. That would be your final answer. So what do you think about this first part so far? Not too bad, I don't think. What?
Every time you said how do you like
No, this part's not that bad, I promise. Alright, so number 1 here, we have a circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. So first thing they want us to do is determine the area of the garden to the nearest square foot. So what area formula are we going to use? Pi r squared. If you didn't remember that, your geometry teachers are not going to be happy. Area of a circular garden would be pi r squared. So what are we going to plug in for our r? 15. So let's have you go ahead and figure that out. To the nearest square foot, what is the area of our garden? Sid? Yeah. 707 square feet. So that's the nearest square foot. It was like 706.8, so that rounds up to 707. So in part B it says, using your area from A, calculate the cost of covering the garden with topsoil. So what would we do for part B? 707 times 1.25. What do we get? There it is. 883.75. It is pretty expensive. That's why I'm always telling my husband we need less gardens and more grass. Let's just make that grass over there. He's like, no, I want to build a garden. I'm like, no. So this example here gets us into our composition of functions. So what a composition of a function is it means it's more than one function put together. And what happens is you plug a number into the first function, which is what we did here in part A, and you took that answer and you plugged it into a different function like we did over there in part B, and then you got your final answer. So that's what happens with your composition of functions, is you take something, you plug it into one function, get an answer, and then take that answer and plug it into another function. So that's what we're doing for the other part of our notes. The way we write that is there's two ways. This is our first way that we write it. And the way this would be read is f of g of x. The other way that we write it is with a little circle, so that it ends up looking like the word fog of x, but it's not. This would also be read as f of g of x. This is just our notation for our compositions. So what happens with these is whatever value they tell you to plug in, you plug it into the middle function first, or the function that's closest to your x or your number that they're telling you to plug it into, and then you work your way out and you plug it into the other one. So for both of these examples, you would plug into the g function first, and then take that answer and plug it into the f function. You just go from the inside out. Let's try a couple of examples. So our first one says f of g of 3. So I'm going to start with the middle part and take the g function and plug in a 3 of it. I got to find g of 3. So if I look up here, here's my g function. So I plug a 3 in for my x, so I get 3 minus 3, which gives us what? 0. So now I'm going to take that 0, and I'm going to plug that into my f function. So that'd be 2 times 0 plus 1. Which, what does that give us? 1. So that's our final answer. Let's try an example number 2. Again, we work from the inside out. So f function is going to go first. I'm going to plug a 4 in for it. So f of 4 would be 2 times 4 plus 1. What does that give us? 9. So now we're going to take the 9 and plug it into the g function. So that would give me 9 minus 3, which would be a 6. Now number 3 is a little different, because are they giving me a number this time? No, they're giving us a letter, but it's still done the same way. I'm going to take the a, plug it into the g function first. So g of a would be a minus 3. Is there any way for us to simplify an a minus 3? No, that's as simplified as it's going to get. So I'm going to take a minus 3 and I'm going to plug it into the f function. So that would be 2 times a minus 3 plus 1. So distribute our 2, I get 2a minus 6 plus a 1. Combine our like terms. 2a minus 5 is going to be our final answer for that one. For number 4, which one are we plugging it into first? G. And then we're going to take our answer and plug it into what? G. This one's using the same function twice. That's g of negative y. No. Composition and multiplication are not the same thing. So here, we got to plug our negative y in for our x first. So I get negative y minus 3. Can I simplify that any further? No. So now I'm going to take that, negative y minus 3, and I'm going to plug it into the g function again. So it's negative y minus 3 minus 3. Which, when we combine our like terms, what do we get? Negative y minus 6. So this is a little different than our operations because you have to plug it into one function first and then plug that answer into the other one. Whereas the operations, you add first or you multiply first and then you plug in whatever they tell you to plug in. So what I want you to do is there's 2 problems on the top here on the next page. I want you to try those ones on your own first. I gave you 3 new functions. Let's see if you can get numbers 5 and 6. So this last part of our notes here is just saying you can do compositions using equations instead of just plugging in a number. You can plug in full equations. To know when you're doing that, your directions would say one of those 2 phrases, either find the rule of the function or it'll tell you to evaluate f of g of x. So again, the rules are the same. You're just not plugging in a single value or a single letter. You're plugging in a whole big chunk of it. So again, I gave us 2 new functions. There's f of x and g of x. So this first one, we start with g of x, but since it's g of x, am I really plugging anything in? No. So it's going to stay as x minus 2. So some people prefer just to rewrite that so they know what it is that they're plugging in. You're more than welcome to, but you don't have to. So we're taking this now and plugging it into the f function. So it would be 2 times x minus 2 squared. Which again, people are still making the mistake. X minus 2 squared. If you don't remember the little trick in your head, write it out twice and multiply. So this will become x squared minus 4x plus 4. So then distribute our 2 and we get 2x squared minus 8x plus 8. That's our final answer. Number 8, they just want us to go backwards. They want us to find g of f of x. So we start with our f of x, but when we plug in an x, nothing changes. It's still 2x squared. So now I'm going to plug 2x squared into the g function. So that gives me 2x squared minus 2. And there's nothing we can do with that. So it stays as 2x squared minus 2. So then 9 and 10, they're asking you the same thing. Again, they're just asking it in a different way. They're trying to tell you to find k of x, which is h of j of x. So that just means for the notation, you've got to write the same notation. You got to keep writing k of x as you go, because that's what they told you to write. So they told us to plug they told us to plug an x into the j function, which when I do that, I still get 3x plus 1. That doesn't change. So I need to now take this and plug it into the h function. So it's going to be 2 times 3x plus 1 minus 3. So we'll distribute our 2 first. So that gives me 6x plus 2 minus 3. So what's our final answer? 6x minus 1. So our k of x equals 6x minus 1. So again, the last one's asking us the same thing, only we're using m of x this time. And they want us to take h of x and plug that one into j of x. So that means it's going to be 3 times 2x minus 3 plus 1. So I distribute my 3. And that gives me 6x minus 9 plus a 1. So what's our final answer? 6x minus 8.